Like sine, cosine, tangent when we graph those? Yeah, do we remember what we kind of did to make sense of them? Plot points. Yes, exactly. Make a list of a table of values, plot all the points, see what it looks like. Right? That's exactly what we're going to do. So, we should create a table of values. But we are in polar coordinates, which are not x and y, but they are r and theta. And now this time one of them isn't just whatever, but they depend on what the other one is, right? So when we put in a specific r, we're going to get a specific theta. When we put in a specific theta, we're going to put in a specific r. Which one do you think is easier to plug in, theta or r? Theta, right? R is all by itself. You plug in theta, you take this. Otherwise, you have to take sine inverse every time. Like, what do we know? So we're going to plug in theta every time. So maybe I'll make my table of theta, and then sine theta slash r, right? You might normally need like 3, but sine theta is r, right? So if we find sine of theta, we find what r is. Or maybe you could just put r equals sine of theta, right? Whatever. Okay. It's a good guess. There is something that does. What is sine of 0? Yes. So this is the point 0, 0, right? R. Now, in our brains, you got to be careful. R is on this side, but here, R is here. We're going to have to, right? That's point 0, 0. Oh, what's another nice angle we know? 30 degrees. What's sine of 30? It's super nice. It's super nice. It's the nice one out of all the ones. Not 1. Okay, maybe not that nice. One half. So that's the point. 1/2 30 degrees. Real quick, because we should probably label how far we're going out. What is the biggest sine can be? 1. So maybe, I don't know, let's label 2. Let's label like all the way out here 1 maybe. Right? And then how 2, 4, 6, 8. So 2, 4, that's going to be 0.5. So 30 degrees at 1/2 or 0.5. So at 30 degrees, we're at 0.5. 45 degrees. Oops. Square root of 2. What's the square root of 2 over 2 in a calculator? Someone do it for me. This one's dead. We need the rechargeable ones. Colin's got me. Square root of 2 divided by 2. Just rough. I got it. Should be a crazy decimal. 1 point what? 1.0 point. Wait. Oh yeah. Okay. So less than. This would be 0.75 right here, right? So 45 degrees. We're like a little bit back here. Okay. What about square root of 3 over 2? Someone got me? Ayúdame, por favor. Square root 3 over 2. What is it? 0.9. So we're really close. So 60. We're where are we at? 60 degrees. I don't know, like here-ish, maybe. 90 degrees or pi halves. Think of the graph. One. Oh. And then think of the graph on the way down. So this is what we've just graphed here. Is it going up? And now we're at that pi halves with that max. It's going to be the same going down. So we're going to roughly get, right, wait, where am I? Maybe more so there, right? And then if we go down there, it's not really going to matter. Because this is going to end it, because then once we pass 180 degrees, sine is what? Positive or negative? Negative. And we're going to kind of get the same values, except now our angle would be down here, right? So it's like, why are we not getting dots down here? But if we have a negative r, it's going to shoot it back this way, right? And we're going to all stay up here. So this actually makes a circle with diameter 1. And if you wanted to, you could just keep cranking out numbers. Yeah. Down here? Yeah. So my explanation was, the book cranks out a whole table of values, like 0 to 360, all the way around.